In this JEE question, we have a block of mass 10 kg which is suspended from a rigid support by the means of an inextensible string of length 4 meters. A force F is applied to the string horizontally such that the upper end of the string makes an angle 45 degrees with the vertical. We have to find the value of F, and we have to take G is equal to 10 meter per second square. Now, we can easily calculate the value of F by the concept of equilibrium and the concept of vector. A string is under tension due to the weight of the body, which is due to gravity. So the weight is 100 Newton, which is mass times acceleration due to gravity, which is we have taken as a 10 meter per second square. So 100 Newton is the weight of the body. So due to that, a tension develops in the string. Now the force F is applied horizontally and the upper end makes an angle of 45 degrees with the vertical. Now let the tension be T. So if you are considering this point with the concept of mechanics, the tension is directed away from the point of consideration. Always remember, when we take the direction, the tension is always directed away from the point of consideration. This is because tension is a pulling force. Now, tension being a vector, as it is a force, we can resolve it into two mutually perpendicular components. So we are applying rectangular resolution of vectors. So T makes an angle 45 degree with the vertical as given. So along this it will be T cos 45, and perpendicular to that horizontally opposing this force will be T sin 45. Now the peculiarity of this angle 45 degrees is that sine and cosine function of 45 degrees is the same, 1 by root 2. So T cos 45, the vertical component of the tension on the upper part will balance the weight, and the horizontal component balances the force. So T cos 45 is equal to 100 Newton and T sin 45 is equal to F. Since both T cos 45 and T sin 45 are equal to 1 by root 2 times T, we have F is equal to 100 Newton. So the answer is option 1. This question is from the chapter gravitation. It's given that at pole a body weighs 196 Newton. We have to find its weight at equator. Now, how does the weight varies according to latitude? We have Earth, of course it's oblate spheroid. We can consider it to be a nearly spherical for calculation purposes. At pole, the weight is due to the gravitational force. At equator, here too the weight is due to the gravitational force. But due to the rotation effect of Earth, all the objects on the surface will be experiencing a centrifugal force. Of course, not much noticeable to us. So the centrifugal force is mr omega square, where r is the radius of Earth, which is given as 6,400 kilometers, and we have to take G is equal to 10 meter per second square as for gravity. So there is a weight acting towards the center of the Earth, which is mg. Here mg only is acting because there is no centrifugal force due to the rotation of the Earth at poles. So mg is given as 196 Newton. So we have to find the weight at the equator, which will be mg minus mr omega square. So weight at the equator is equal to mg minus mr omega square. Angular velocity of rotation of Earth is not given, but we can easily find that using the relation 2 pi over t, where t is the time period of the rotation of Earth, which is 24 hours. We can convert it into seconds by multiplying with 3600. So mg will be the weight at pole 196. So the mass will be 19.6 multiplied by radius of the earth, which is 6,400 kilometers. We have to convert it into meter, multiplied by omega square, which is 2 pi divided by time period square. This will give us the answer, which is equal to 195.33 Newton. Option 3 is the answer. So we have a question from current electricity. In a house, there are 15 bulbs of 45 watt each, 15 bulbs of 100 watt each, and another 15 bulbs of 10 watt each. And there are 2 heaters which are 1 kilowatt each. All these are connected to 220 volt main supply. And we have to calculate the minimum fuse current. So we will make use of the relation P is equal to VI. Power is equal to potential difference multiplied by current. Now, how does this relation come? Power is the rate of doing work done to displace Q charge across a potential difference V is QV. Q over T, that is rate of flow of electric charge, is the electric current. So we have P is equal to V times I. In order to find out the minimum fuse current from these conditions, we have I is equal to P divided by V. For this, we have to calculate the total power, which is 15 multiplied by 45 plus 15 multiplied by 100 plus 15 multiplied by 10 plus 2 multiplied by 1000. So the current minimum is given by the total power divided by the potential difference 220 volt. This yields 4325 divided by 220, which is equal to 19.66 ampere. Now, from the given options, the best option is 20 ampere. This question is from Rotational Dynamics. We are having a disk whose surface mass density varies with aerial distance as sigma is equal to A plus BR. So that means as we move from the center of the disk towards the outer surface, its density varies. So the mass per unit surface area is not constant. It varies according to this given relation. And also it is given that the disk is having a radius A. We have to calculate the moment of inertia of this disk in terms of these constants A and B when the disk rotates about an axis passing through its center and perpendicular to its plane, like this. For extended rigid body, we have to find the moment of inertia as I is equal to integral dm r square, where dm is the mass of a fine element or finite strip of mass of the given rigid body. Now, how will we consider a strip of mass here? As following the usual rule of symmetry, we will take a circular strip of mass. So this is a disk having radius A. We will take a circular strip of radius R, and the circular strip is having a thickness dr. We can calculate the mass dm of this strip and apply it here, because the disk is constituted by numerous such strips. Each strip will be having radius varying from 0, which will be at center, to maximum A. So the disk is constituted of numerous circular strip of mass, each having an infinitesimally small width dr and whose radius varies from 0 to A. Since the areal density of the disk is given, we can easily calculate the mass of this strip. So dm is equal to areal density, that is the surface mass density, multiplied by area of this strip. So the surface density is sigma, which is A plus BR, multiplied by the area of the strip. The area of the strip is equal to 2 pi r dr. This is because this circular strip, when stretched, will be like a rectangular strip of length 2 pi r, that is the circumference of the strip, and it will be having a width dr. So the mass of this strip is A plus BR 2 pi r dr. We can substitute that value here and integrate with the limit from 0 to A to calculate the moment of inertia of this disk. We have used this particular formula because when the disk rotates about the given axis, this circular strip will be like a ring rotating about an axis passing through its center perpendicular to its plane. Therefore, we have the formula equivalent to that of a ring. Thus, the moment of inertia of the disk about the given axis is equal to I equal to integral 0 to A, as the strip is the radius of the strip is increasing from 0 to A to constitute the entire disk. Integral 0 to A dm r square. So dm is A plus B r multiplied by 2 pi r dr. So that is dm multiplied by r square. So we have integral 0 to A plus B r 2 pi r dr, which is the mass multiplied by r square. Now integrating, now applying limits, we will be replacing r with A, and the minus lower limit will be 0. Applying the limit, we have 2 pi A raised to 4 by 4 plus B A raised to 5 by 5 minus 0. So we can take A raised to 4 common as compared with the answer options and write this as A divided by 4 plus B A divided by 5. This is the answer option, which is option 1.